All right. Now we're on to module 2, which is the module that we're on for the week. All right. And it says right here, a sequence, and the sequence is given by Tn, is defined by the recurrence relation. Tn plus 1 is Tn plus 5, and T1 is 11. It says find T2, T3, and T4. Let's just write that right here. To find T2, T2 is Tn. When n equal 1, put n as 1. When you put n as 1, you get T2. T2 is T1 plus 5. T1 is 11. 11 plus 5 is 16. So that's T2. We can find T3. T3 going to be T2 plus 5. 16 plus 5 is 21. And then we're able to find T4. T4 is going to be T3 plus 5. And T3 is just going to be 21 plus 5, which is 26. All right? So that's going to be all of those right there for T2, T3, and T4. All right? So that's going to be those. Now it says, find an expression for Tn. All right? So let's find an expression for Tn. All right, so let's find the expression for Tn. So to find the expression for Tn, what I like to do first is write out the order of the list of the numbers. Write them out. It's 11, 16, 21, 26, 31, and it would continue. So what I realize is that this would be an arithmetic progression. All right, this would be an arithmetic progression. So if this is an arithmetic progression, how do we write an expression to represent the nth term of an arithmetic progression? The nth term of an arithmetic progression, Tn, is equal to the first term. We usually call the first term A plus n minus 1 times the common difference. N minus 1 times the common difference. That would express the nth term. So what we're going to end up get for this nth term is the first term, which is 11, plus n minus 1 times the common difference. The common difference is 5. So it's 5 times in bracket n minus 1. That's the nth term. And so what we end up getting now is that the nth term is equal to 11 plus 5n minus 5. That's it. Just put it in as 1 now. We're going to get that the nth term is equal to 5n plus 6. That's the nth term. 11 minus 5 is 6. And they're giving 5 marks for this. That's the nth term. All right. 5n plus 6. All right. All right, so cool with this for the nth term.
Yes, sir.
All right. All right. Now this one right here now says find the range of values of x. All right, give me a second. All right. So this one right here now says find the range of values of x for which the common ratio of this geometric progression is convergent. Now this is a very weird looking question. Let's read again. Find the range of values of x for which the common ratio of a convergent series is this. Oh, so they're telling you this is the common ratio. All right. So the common ratio R, they're telling you that R, which is the common ratio, is equal to, the common ratio R is 2x minus 3 over x plus 4. 2x minus 3 over x plus 4. Can you hear me?
Yes, sir.
Yes, sir.
All right, good. All right, now, right here, so now, when is the geometric progression convergent? When is a geometric progression convergent? A geometric progression is convergent when the modulus of R is less than 1. So let's make notes of that. A geometric progression is convergent when the magnitude of R, the modulus of R is less than 1. That's when a geometric progression is convergent. All right? We'll call it this.
Yes, sir.
So now, what does that mean? A geometric progression, see R there? R, the modulus of R is less than 1. So what we're ending up solving now is 2x minus 3, the modulus of it, over x plus 4. We need to solve that the modulus of this is less than 1. The modulus of this is less than 1. Now, guys, if we're solving the modulus of this is less than 1, then that implies pre-this knowing or pre-this. What we're going to end up getting now is 2x minus 3. The modulus of that is less than the modulus of x plus 4. That's what we're going to get right there. You might say, sir, how you get that? If you have the modulus of the whole thing, you can actually break it up really and truly as the modulus of the numerator over the modulus of the denominator. And then we can multiply through by the denominator. So this is what we're going to end up get. So guys, in order to do this now, what you're going to have to do is square both sides. Square both sides to get rid of the modulus. Square both sides. So we're going to end up get 2x minus 3 all square is less than x plus 4 all square. All right, that's what we're going to end up get. Now, when we get this now, we end up with a quadratic to solve. It's going to be first term square, 4x squared, minus twice the product of the 2. 3 times 2 is 6. 6 times 2 is 12, so that's minus 12x. Plus the second term square, 3 squared, which is 9. And that's less than first term square, which is x squared, plus twice the product of the 2, which is 8 times 2 times 4 is 8, say 8x, plus second term square of 16. All right, nice. So now we can bring it over to one side. I'm just going to finish it off right here. All right, since I have some space, so we're going to go from this line to this part over here. Let's change the color. Bring over x squared over here, so make it come 3x squared. Bring over 8x over here to make it become minus 20x. And then we can bring over the 16 over here. 9 minus 16 is minus 7. And this is less than 0. So then now, guys, I end up with a quadratic inequality, and you can factorize, and that is less than 0. So know that since this is 7, it has to be 3x and x, 7 and 1. I think the 7 has to go here, and the 1 has to go here. And it says signs are different, the greater product negative. So minus come here, and the plus come right here. So that means that the final answer there is that x would end up work out to be between 7 and -1/3. Those are the values of x that will make the common ratio be less than 1, hence making it a convergent series. All right, x has to be between -1/3 and 7. All right, we're cool with this? This wasn't spicy at all. The only thing you had to know from unit 2 was that for a convergent progression, the modulus of r is less than 1. Literally after that, you go back to basically add math.
Sir,
All right, regular, yeah.
what year is this?
This is 2009.
Oh, okay.
All right, what you saying? This is a challenging paper, don't?
Well, it's just never really that hard.
Yeah. Not that hard. Yeah, for real. But it's just different, right?
Yes, sir.
Yeah, it's way different. That's what happened in them paper there. And I just suspect that something is going to repeat. Between 05 to 08, half of the paper going to repeat. I have a strong feeling, all right, that I can't shake off. Guys, when you come out of the test, you show me the paper and I say, sir, Michelle, everything repeat. I'm just going to say yes, all right? So that was that one right there. So that wasn't bad. Now this was a question that came on the mock exam, but I didn't put the second part right here. I gave you f of r is 1/r plus 1, and I asked for f of r minus f of r plus 1. This was where I took part ci, and then I made up my own part 2. So I didn't bother to give you the exact summation. I made up my own part 2. So hence, with my own summation. But I took part 1 from right here. So let's look at how we actually work out the part 1 now. All right, so f of r is 1/r plus 1. And we need f of r minus f of r plus 1. So let's write down f of r. F of r is 1/r plus 1. Nice, we don't have nothing to worry about. That's f of r. And we need f of r plus 1 too. So that would mean that f of r plus 1, if we really want to work it out, f of r plus 1 would be replacing r with r plus 1. So f of r plus 1 is 1/r plus 2. Yeah, man, that's f of r plus 1. So that means the f of r minus f of r plus 1, what we're going to end up getting now is we're just doing the subtraction of these two. That's it. We're just going to subtract these two. So it's just going to be 1/r plus 1 minus 1/r plus 2. Now to do this subtraction, guys, it works out to be one little fraction. All right, so we have to multiply their denominators to get the LCM, r plus 1 times r plus 2. And then now after we do that now, r plus 1, oh, this is r plus 2. Why write r plus 1? R plus 1 times r plus 2. Now we're going to say r plus 1 into this goes r plus 2. 1 times r plus 2 is r plus 2. So end up with r plus 2 minus in bracket r plus 2 into this, leave r plus 1. So minus r plus 1. Now guys, r minus r gone. 2 minus 1 leave 1. So this work out to be 1/r plus 1 times r plus 2. And that's it. That's f of r. That's f of r minus f of r plus 1. R plus 1/r plus 1 times r plus 2. That's it. Literally, that's it. All right. So that would give you.
So we missed the part where you find f of r plus 1. Oh, you do. Oh, you get that.
All right, so what we did was replace r right here with r plus 1. Replace r with r plus 1. All right. For example, if you were asked to find, if this is f of r and they ask you to find f of 3, what you do is replace r with 3, don't you? Write 1/3 plus 1, right? Right?
Yes, sir.
So the same way we're going to replace the r right here, so with r plus 1. All right? That becomes r plus 1 plus 1, and r plus 1 plus 1 is r plus 2. Make sense now? All right. So that's how we end up get that. So that would be f of r plus 1. So just for clarity, right? Let me stop skipping. This is really r plus 1. This is where we replace it with r plus 1. All right, so we'll follow smoothly. That's what we'd have there. So now, the next part says, hence, evaluate the summation. Now, this is a method of difference question. It says, hence, evaluate the summation. So let's look at how we're going to do this. All right, so it wants us now in part 2. Part 2 right here, it wants us to evaluate the summation. We're going to evaluate the sum from r equal 1 to n of 4 over r plus 1, 4 over r plus 1 times r plus 2. Now guys, look at this, good. If we were to multiply this by 4, that would end up tell us that 4 times, because remember this left side, by the way, is f of r. This is f of r minus f of r plus 1. So if we were to multiply f of r minus f of r plus 1 by 4, that would be 4 over this. So what does that mean? That means that this summation is equal to 4 times the sum of, it's 4 times the sum of f of r minus f of r minus 1. Right, it is 4 times this summation. Yeah, man, it's 4 times f of r, which is 1 over r plus 1, minus the sum of f of r plus 1, which is 1 over r plus 2. All right, it is 4 times this. Right, it's just the sum of f of r minus f of r plus 1. Let me not skip any step. I'm going to write out the word because I want it to be extremely clear. It is 4 times the sum of this expression right here. If I were to break up this, I'm going to put the 4 on the outside. I'm going to put the 4 on the outside, put the 1 on the inside. But we already deciphered that the 1 right here, the 1 over r plus 1 times r plus 2, all of that right here is f of r minus f of r plus 1. So this is 4 times the sum of f of r minus f of r plus 1. It's 4 times the sum of f of r minus f of r plus 1. Then we can actually work it out now. So it's going to be 4 times the sum of f of r minus the sum of f of r plus 1. Because remember, we can break up summation like that. The sum of a minus b is the sum of a minus the sum of b. All right, so that is what we do. And then whatever sum we get, we multiply it by 4. All right, so this is what we're evaluating. So since this is what we're evaluating now, what we're going to end up getting now is, let me see, we go around here now because we don't have enough space. So evaluating it, that's now going to be equal to 4 times in bracket. Guys, let's put in our left-hand side. Let's put in values now for f of r. F of r is 1 over r plus 1. When you plug in r as 1, you get 1 over 2. So over here, so now you're going to get 4 times 1 over 2. Then you're going to get plus r as 2. Now you're going to get 1 over 3. Plus, you're going to put r as 3. You're going to get 1 over 4. And you're going to keep on plugging in values of r till we end up get 1 over r as n. We get n plus 1. Then it is minus now, we'll plug in f of r plus 1. In f of r plus 1, it's r plus 2. See, the f of r plus 1 is r plus 2. Plug in r as 1, you get 1 over 1 plus 1 plus 1, which is 1 over 3. Then it continues. So on this side, it starts from 1 over 3. That don't look like 3 at all, so let's fix that. 1 over 3 plus 1 over 4 plus 1 over 5, and it's going to continue and continue and continue until we reach 1 over. Plugging in r as n, we're going to get 1 over n plus 2. This is what we're going to get. So now when we're going to do the subtraction now, what we're going to end up get is the 1 over 3 here, so minus the 1 over 3 here, so going to cancel. The 1 over 4 here, so you can cancel the 1 over 4 here, so the 1 over 5 here, so going to cancel the 1 over 5 here, so and it got 1 over n plus 1 here, so going to cancel the 1 over n plus 1 here, so and so finally what we're left back with is 4 times in bracket. This is then going to be half minus 1 over n plus 2. That works out to be 4 times a half minus 1 over n plus 2. This is what we end up get. All right. All right. All right, Sherry. So take care. All right. Take care, Sherry. All right. So guys, this is what this work out to be. All right. So now that's it. You can leave it like this. They didn't say we need to simplify it. They didn't say to prove. So anytime they don't say prove, you can leave it just as that. I will leave it just as this. All right. So find the sum. We end up write it as, I don't want to simplify it any further. I just write it as 4 times a half minus 1 over n plus 2. That's where this work out to be. Now guys, it says hence we need to find the sum. To find the sum now guys, deduce the sum, you're going to replace n with infinity. So deduce the sum to infinity. The sum to infinity going to be equal to, replace n with infinity, we're going to get 4 times in bracket. This right here is a half, so it's going to just become a half minus 1 over infinity, but 1 over infinity is 0. 1 over infinity is 0. And so that means, guys, since this is 0, we get 4 times a half. 4 times a half is 2. All right, 4 times a half is 2. So that's the sum to infinity. Because 1 over infinity is 0. All right. So cool with this one. Cool with this question.
Boy, I need some work on that topic here.
Yeah, all right, don't worry. So tomorrow I'm coming with loads of questions. All right, as I said, more from longer paper 05, and I see some that are digging up from 2002, 2001. All right, and I'm gonna come with them, and we just need whole heap of practice with these. All right, and we're good. All right, don't worry, we're gonna be really good, man. All right, and I'm still trying to dig up even some more paper one. I want to get paper one from 07 coming back. All right, trying to get some 07 coming back up just to be safe, because paper one started 06 for unit 2, the multiple choice. I want to have all of them. All right, so now this one now, number 4, is a little bit different. It says find the value of n where n is an element of natural number such that 5.
Sorry, it's a little bit blurry.
Yeah, it's a blur. So I'm going to tell you what it is. I'm going to rewrite it right here. It's really blurry, even for me. It is saying 5 times n. Oh, let me fix the 5. It is saying 5 bracket 5 times n choose 2. It is saying that this right here, 5 times n choose 2, is equal to 2 times, in this bracket, it is n plus 2 choose 2. Now we need to find what n is that satisfies this equation. All right, so let's write this out on the white screen under this. All right, so let's go to a new page. We have 5 times n choose 2, and this is equal to 2 times in bracket, that again was n plus 2 choose 2, n plus 2 choose 2, and we need to find the value of n so that these are going to be equal. All right, so to find the value of n so that these two are equal, well, the first thing we need to do is remember n choose r formula. So we have to know n choose r, guys. Remember this formula, and we have to know it by heart. It is n factorial divided by r factorial multiplied by n minus r factorial. That is this right here, n factorial over r factorial multiplied by n minus r factorial. So what that means, therefore, is that this can be written as 5 times in bracket. This is now n factorial. R in this case is 2. So it's n factorial over, this is r is 2, so it's 2 factorial times, this is then n minus 2 factorial, n minus 2 factorial, close the bracket. All right, so close that bracket. And this is equal to, this is now 2 times, your n now you replace it with n plus 2 factorial. So this is now n plus 2 factorial. So you put a bracket, put a factorial. This is being divided by your r factorial, which is still 2 factorial. And it's being then now in bracket n minus r. This is your n plus 2 minus 2 is then n factorial. That's now n factorial. All right, close up the bracket. So now we need to solve this equation for n. To solve this equation for n, guys, remember that 2 factorial is just 2. So this 2 factorial cancel this 2 right here. All right, we're cool so far. Now look at this, n plus 2 factorial over n. N plus 2 factorial, remember, it is n plus 2, and then that is going to be multiplied by n plus 1, and then that is multiplied by n factorial. That's then multiplied by n factorial. And this is then divided by n factorial.
Wait, so you
All right?
cancel the 2 and the 2 factorial?
Yes, 2 and 2 factorial cancel. Yeah?
Oh, yeah,
Cool
yeah,
with
yeah.
this?
Makes sense.
Okay. Because 2 factorial is 2. All right? And then expand n plus 2 factorial as n plus 2 times n plus 1 times n factorial. All right? And why did we expand? So we can cancel the factorial. We needed to cancel this factorial. So now we notice the n factorials them cancel. That's on the right side now. Let's cancel out on the left side. 2 factorial is 2, so we can rewrite this as 5 over 2. And then what we notice is that n factorial can be written as n times n minus 1 times n minus 2 factorial. So then the n minus 2 factorial cancel the n minus 2 factorial in the denominator. These two are going to cancel each other in the denominator. Dum, dum, dum. So this cancel, n minus 2 cancel, the n minus 2, those factorials cancel. So now, guys, we end up with an easy equation. 5 over 2 times n minus 1 equal to n plus 1 times n plus 2. We end up with an easy equation to solve now. Yeah, man. So how can we solve? First thing I would do is multiply through by 2, because I don't like how that look right there. If I multiply through by 2, I end up get 5n.
But the prover proves that the two sides them equal.
No, we're not proving, we're solving for n.
Oh,
The whole point of this question is to find what is the value of n so that these two combinations are equal to each other. All right, if it was a proof, we'd have been showing the left-hand side equal to the right. All right, so we're finding what's value of n that's going to make these two combinations equal. So by multiplying through by 2, this is going to be 2 times n plus 1, n plus 2 times n plus 1. So guys, we end up with 2 quadratic on each side to simplify. So now we can simplify it in one step now. N times n is n squared. N times minus 1 is minus n. Then we times it by 5. So this is just 5n squared. Doing it in one go. Minus 5n equal to, over by this side, it's going to be n plus 2 times n plus 1. That's 2. N times n is n squared. When you expand this now, n times 1 is n plus 2 times n is 2n, so that's 3n times 2 is 6n. Then we have plus 4. All right, so that's what they simplify to be. Yeah? Nice. All right, so no problem. Let's go back through this then from the start. All right, so let's go back through from the start then, Roshan. All right, so look at this. It says, find the natural number n such that these two combinations are equal to each other. All right, find the natural number n so that these two combinations are equal. All right, so let's go back now, Roshan. So the first thing we said is we write down this formula that you must know. In order to find n, this is the formula that we're going to apply. Right, Roshan? This formula, right?
Yes, sir. Yes, sir. I never meet asking, sir.
Okay, no problem. All right. So let's go back now. So let's go back through now. And so this right here, we have this right here, and we're applying this formula. So remember, n choose 2. To find n choose 2, you replace r in this formula with 2. So replace r with 2 to get 2 factorial here. N minus r become n minus 2 factorial. So we have n factorial over 2 factorial times n minus 2 factorial. And it is being multiplied by 5. On the right-hand side, we replace n now with n plus 2 factorial for here. And then we replace r right here with 2. So if you replace r right here with 2, you get 2 factorial times. Replace n with n plus 2, you get n plus 2 minus 2. N plus 2 minus 2 is n. So that's how we get this n right here. Cool it this? We cool it this now? The second line cool?
Yes, sir.
All right, cool, cool, cool. Now that that line is cool, now the third line right here now, as we can see, the 2 cancel the 2 factorial. Why? If you put 2 factorial in the calculator, you get 2. 2 over 2 factorial is 1, so those cancel. Now, all we need to do now is simplify this right here. But n plus 2 factorial is n plus 2 times n plus 1 times n factorial, and it is being divided by n factorial. So the n factorials cancel. Just think about it with numbers. 6 factorial divided by 4 factorial. I can tell you that 6 times 5, which is 30. Check it out. 6 factorial over 4 factorial, you get 30. How did I do that so fast? 6 factorial, because it is 6 times 5 times 4 factorial, then the 4 factorials cancel. So the same thing we do if it was a letter. N plus 2 factorial is n plus 2 times n plus 1 times n factorial. The n factorials cancel. On the left-hand side now, we have n factorial over 2 factorial times n minus 2 factorial. So as we can see right here, this can be simplified n factorial to n times n minus 1 times n minus 2 factorial. The n minus 2 factorials then cancel. So left back with 5 over 2 times n minus 1 equal to n plus 2 times n plus 1. We call it this. Cool it this now?
Yes, sir. Yes, sir.
All right, now we end up just get an easy quadratic to solve. Like guys, just most time keep lead to either quadratic or simultaneous equation. It always just lead to a quadratic or a simultaneous equation, or a quadratic inequality. Let us always lead back question there. So finishing this off now down here, we can bring over 2n squared to end up get 3n squared. We can bring over the 6n over here to get minus 11n. Then we can, wait, is this, let me see this. This is n squared plus 3n, yeah, this is right. So this is 11n. Then we can bring over the 4 to get minus 4 equals 0. All right. All right, now we need to find what is n. So we need to factorize it now and find what is n. So we're almost done, we're literally done. We just need to find what is n by factorizing. I think this is 3n. I don't want to factorize it incorrectly. Let's go again. This is 3n, and this have to be n. It have to be maybe 2 and 2. Would this work? This time this is 6. This one give me 11. This one give me 11, so 2 won't work. Let me try 4 here. And 1 here. That won't work either. So let me put the 4 here. Yeah, this work. Put the 4 here so and the 1 here so. So then this work, and I put the minus here so and the plus here, so this work. So guys, what we end up getting is n equal negative 1 over 3. But guys, n can't equal negative 1 over 3. This one is not valid. That's because you can't get a negative combination. You can't use n as a negative in combination. So n equal 4. That's the answer that's going to make these two sides equal to each other. N equal 4. Now I'm going to take out my calculator. I'm going to take out the next one, and I'm going to show you that n is indeed 4. All right, I'm going to show you that n is indeed 4 with the two calculators displayed on the screen. All right, now the calculator is not able to solve the equation, but it's able to show you the solution of the two of them to be equal. How am I gonna do that? Let's look. So n equal 4, that's what we get. I'm gonna take out the two calculator them, boom, boom. So we have the two calculator. So when n equal 4, your left-hand side would be 5 times in bracket, n is 4. If n is 4, it's 5 times 4 choose 2. 5 times 4 choose 2 would be a left-hand side. 4 choose 2. 5 times 4 choose 2, 30. Let's look at the right-hand side. If n is 2, this would be 2 times in bracket 4 plus 2 is 6. Is 2 times 6 choose 2. 6 choose 2. Guys, you see it? What do two of them say when n is 4? When n is 4, two of them equal what? 30, we see it? Right? We see it now? So n equal 4?
Yes, so it seems that them equal.
Yeah, so n equal 4. That's how you'd find n. All right? So n equal 4. All right? So n equal 4. Cool? All right, we'll cool it up.
Sure.
All right, so this one now says, find the coefficient of x squared in the expansion of 1 plus 2x all cubed times 1 plus px to the 4. All right, we need to find the coefficient of x cubed. And I love questions like this. So this came on the mock exam. Well, actually it told us the coefficient of x cubed is negative 26. Find the possible values of p. All right, so let's do that question here. All right, so just to write that out, we have 1 plus, this is 1 plus 2x. Can't even see that. Is that cube or to the 5th? Is that to the fifth or cube? What is this paper doing? My God. Is that cube or fifth?
So we have to go back so we see it.
All right, let's go back. And you can decide and tell me. Is this a cube or to the fifth?
That blurry bud still.
This blurry bad, like I don't know who compiled this PDF together. This is awful pictures they scan. This is awful. All right, let's take it as cube. No, I don't want to take it as cube.
Yeah,
It
what
might not be
paper
cube.
is it?
This is 09.
All right, so I can look and see.
All right, tell us then. All right. I'm just gonna put our dash for now. It's 1 plus 2x to the something. We don't know what that something is. All right. And then it is multiplied by 1 plus px to the 4. 1 plus px to the 4. All right, so what was it? Was it cube?
First to the fifth.
It was to the fifth. All right, to the fifth. No problem, no problem, no problem. And the question told us that the coefficient of x squared is negative 26. That's what they told us. So look how easy we're going to shell off this now. If the coefficient of x to the fifth is negative 26, what we're going to do is just, guys, if you expand out this, right? If you were to actually expand out this to the fifth power, guys, we can expand. It's, remember, it's the first term to the fifth plus it's 5 times the first term times, it's 5 times the first term to the fourth times the second term to the first power. We did this in complex numbers, how to expand a plus b to the fifth using Pascal triangle. It's 1, 5, 10. Then it is 10 times 1 cube, then multiplied by 2x being squared. Then it is plus another 10 again, 10 times x, 10 times, right here, so it's now 1 times 2x being cubed. And then we have plus, this is a cube, by the way, cube. Then it is plus 5 times 1 being, wait, this is squared. This is to the 1. This is now 2x to the 4th power. And then we have plus, then 2x to the 5th. All right. So that's what you would end up get when you expand this right here. We're expanding this, the 1 plus 2x to the 5. All right, this is what we're expanding, 1 plus 2x to the 5th. Cool it this?
Yes, sir, yes, sir.
All right, so that's that part right there. So let's simplify this now. So simplifying this now, what we're going to get is 1 plus, remember that 5 times 1 times 2, that's just 10. So this is 1 plus 10x plus 10 times 1 cube is 10, 2 square is 4. So that is 40. This is now 40x squared. And then right here, so now what we have is 10 times 2 cube is 8. 10 times 2, 8 times 10 is 80. So we get 80x cubed. All right, plus this is then 2 to the 4, which is 16. 16 times 5 is also 80. So this is 80x to the 4 plus 2x to the 5 is 6. 2 to the 5 is 32. 32x to the 5th. Now you might say, sir, so why you go and expand all of that? We expand all of this because remember, we're going to have to multiply it by 1 plus px to the 4. No, guys, you're not going to expand 1 plus px to the 4. You can, but we're not going to. to find out what the coefficient of the x squared term is, you would need the x squared term in each of the expansions. So if we were to break this down even simpler, we know it would be 1 times all of this. So it would be 1 times 1 plus px to the 4. Guys, pay attention. This was in the mock exam. This might come this year. 1 plus px to the 4 plus, if you were to actually write it out, it would be 10x times 1 plus px to the 4. It would be 10x times 1 plus px raised to the 4. Then it would be plus 40x squared times 1 plus px to the 4, and we'll get the gist. 40x squared times 1 plus px to the 4. Now, we can stop right here, so. Now, why do we stop right here, so? Anybody tell me why we can stop right here, so?
As I asked for the second
Very,
square.
very good. Then answer the coefficient of x squared. So if you multiply x cubed times anything over there, so you're gonna get a term bigger than x squared, you're gonna get x cubed and add. So what we need to do is to find the coefficient of x squared in this. The coefficient of x squared in this, what we're gonna do is use, this is 4, so it is 4c, x squared would be 2, 4c, 2 of 1 times this right here, so is, this right here so is px squared. Then now it's plus, guys, it is plus pre this now. If you get the coefficient of x squared in this expansion, pre this good now, you know, if you get the coefficient of x squared in this expansion, it is 10x times, look at this now, you're choosing 1, n is 4, and it is 1 times p, 1 cube times px, 1 cube. Now, why did we only choose 1? We choose 1 because we only need an x here, so when we multiply it by 10x, we get an x squared. We multiply it by a 10x, we get the x squared. That gonna give us the coefficient of x squared. Then we have plus 40x squared times 1. Now, why is it times 1? Because, guys, we only need the 1 to the 4, which is 1. This is already giving us the x squared. We'll call it this. Call it this.
I'm not ready to understand where do you listen.
All right, let's slow down and go back through it. Now, follow this now. If you were to expand out 1 plus px to the 4, you would get 5 terms, don't it? You would get a constant, an x term, an x squared term, an x cubed term, and an x to the 4 term, right?
Yes, sir.
If you do 4 choose 2 times 1 times px squared, that will give you an x squared term. Don't remember also to find any term in an expansion. It is to get the x squared term, you put 2 right here, so. And so then it is n, choose r, it is 4, choose 2 of 1 square times px all squared. This is going to give you an x squared term. Cool it this? You cool it this part though for your x squared from this.
Yes, sir.
Now this is the troublesome part, right? Why did I choose 1 down?
Yes, sir.
Now look at this. We just said if you expand 1 plus px to the 4, you're going to get a constant, you're going to get an x term, you're going to get an x squared term, you're going to get an x cubed term, you're going to get an x to the 4 term. But if you get right here, so, if you get an x term here, so, and you times it by 10x, the x term times the 10x, don't that give you x squared? That makes sense?
Yes, sir. Yes, sir.
Yeah, and then over here, so the constant times the 40x squared gonna give away x squared term, don't?
Yes, sir.
Nice. And now we just equate this to negative 26x squared. And this is what we'll do to solve for p. All right, that's literally it. So now we just have to solve this now, and we're good. So now, all we do, 4 choose 2. I don't remember what's 4 choose 2. That's really sad. I'm gonna punch it in the calculator. All right, let's punch these in the calculator. 4, choose to 6. So 4 choose 2 is 6. So this is now 6 times 1, which is 6 times px squared. That is 6p squared x squared. Now here, so now 4 choose 1 is just 4. 4 times 10, that's gonna be plus. This is now 40. 4 times 10, that's 40. X squared times p plus 40x squared. And that's equal to negative 26x squared. This is 40x squared and it equal to negative 26x squared. So in order to solve for p now, guys, what you're gonna do is divide through by p. Divide through by p. Divide through, not by p, by x squared, sorry. Divide through by x squared. All right. So if we divide through by x squared, you're gonna realize that, oh, this should have an x squared here. Dividing through by x squared, we're gonna left back with 6p squared. You're gonna left back with 6p squared from that side. Dividing through by x squared, we get plus 40p plus 40p. Then right here, so now, divide through by x squared, get plus 40 equal negative 26. So you write plus 40 equal negative 26. And you get a quadratic and you it easy and nice now. Look how this easy now. Bring over the negative 26 to get, add 26, 40 plus 26 is 66 equals 0. Was it 26 or was it 28? Let me check that. Because that could have divided through by 4. Yeah, negative 26 is good. So bring it over, it's now 66 plus 40p plus 6p squared. And this is what we're going to use to solve for p. All right. So now let us divide through by 2. Dividing through by 2 is going to give us 3p squared plus, that become 20p, that become plus 33, and that equals 0. Now, can we factorize it? I have no idea, so I'm going to go straight to my calculator. 3p squared plus 20p plus 33. I'm just going to go straight to the calculator. It would be minus b, 3p squared plus 20p, so it's minus 20, plus or minus the square root of b squared, which is 20 squared, minus 4 times a, minus 4 times 3 times 33 divided by 2a, which is being divided by 2 times or coefficient of a 3, that is negative 3. That's one answer, negative 3. What's the other value for p? The other value for p is when we change this to a minus sign. So p is negative 3 and p is negative 11 over 3. So solving this quadratic, now just for trick them, to make them think so sharp, we know say p is 3, so make them think so sharp, make them think so never quadratic we use. We just put 3p, p, 11, 3, plus, then we can tell them say p equal negative 11 over 3, or we can tell them say p equal negative 3. Yeah, we'll call it this. We'll call it this. Yeah, man. So since 2009, them time at the paper, them nice, no? ln 1 plus 2x and state the region where it is valid. Now, first thing we have to remember about ln is that the log of a negative don't exist. So we know it's only going to be valid when 1 plus 2x is greater than 0. So we can decide for where it is valid. Before we can expand it, we're going to use Mclaren formula. So you have to remember Mclaren formula. Mclaren formula tells us that f of x is equal to f of 0 plus f prime of 0 times x, f prime 0 times x, plus f double prime 0, f double prime of 0 times x squared over 2 plus f triple prime of 0, f triple prime of 0 times x cubed over 3 factorial, which is 6, and so forth. This is Mclaren power series. Yeah, man, you have to remember them. This is Mclaren power series. So this is what we're going to be using now. So what we're going to end up getting now is that this right here, right down here, f of x is ln 1 plus 2x. So you need your f of 0. So to find f of 0, you replace x with 0. So that means f of 0 is equal to ln 0, ln 1, sorry, and ln 1 is 0. So that's f of 0. That's still not a non-zero term. We need to differentiate to get f prime now. So f prime is going to be equal to, differentiating ln 1 plus x, we're going to get 2 over 1 plus 2x. Yeah. Or you can rewrite it as 2 times 1 plus 2x to the negative 1. Just rewrite it this way so it's easy to differentiate. Yeah. Now, since this looks easy to differentiate, we can end up finding now what is f prime of 0. And f prime of 0 would be, we'll plug 0 in here, and we'll get 2. Then now we need f double prime. F double prime is going to be equal to, carry down the power to get minus 2, subtract 1 from the power, 1 plus 2x to the minus 2, but then we multiply it by the derivative inside the bracket of 2, and so the 2 times the minus 2 is negative 4. That's negative 4 times 1 plus 2x to the minus 2. So that implies that f double prime of 0, we end up get that going equal to negative 4. And then to get our third derivative now, f triple prime, f triple prime is going to be, we carry down the power again, minus 2 times minus 2 is now positive 8. We subtract 1 from the power to get 1 plus 2x to the minus 3. And then we multiply by the derivative in the brackets of 2, but 2 times 8 is 16. So we get 16 times 1 plus 2x to the, that is negative 3. Nice. So that implies that f triple prime of 0, we're going to end up that is equal to, that looks like 16. All right, so good so far. Now is where we're going to substitute back in Mclaren formula and tell them no. So that means that ln 1 plus 2x is equal to f of 0, which was 0, plus f prime of 0 times x, f prime, which we found to be 2 times x. So that is now 2x plus f double prime was negative 4, x squared over 2 factorial, which is over 2, plus f triple prime, which we found to be 16, x cubed over 6. We're done. To simplify now, we end up get 2x minus 4 cancel, this cancel, we get 4 over 2 is minus 2x squared, and then 16 over 6, we end up get 4, well, 2 into this is 8, and 2 into 6 is 3. I will finish. That's it. Nice. That's 2x minus 2x squared plus 8 over 3x cubed. That would be the expansion of ln 1 plus 2x. Now, I don't know why they only put 2 marks, because that's crazy, right? They only give 2 marks for that, but well, oh, and we don't even finish. They wanted the first 4 non-zero term. So looking at our expansion, we only have 3 non-zero term. So we needed to go one more. We need to find f prime prime. F prime prime prime. Let's write it up here. F prime 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 prime. That would be equal to, differentiating this one last time, minus 3 times 16 would be minus 48. That would be minus 48. 1 plus 2x to the minus 4. And then you multiply it by the derivative inside of 2. So that implies that f prime prime prime, or f to the 4 of 0, we'll end up get that is 2 times minus 48 is negative 96. All right, so continuing, this would be, of course, plus f prime prime prime, which is negative 96, x to the 4 over 4 factorial, and 4 factorial is 24. So divide it by 24. Negative 96 over 24, that is minus 4. That's minus 4x to the 4. 2 marks for this, that's crazy. And to state where x is valid, it is valid when 1 plus 2x, this has to be greater than or equal to 1. So cancel the 1 there, and so it's valid when x is greater than or equal to 0. That's when this expansion is valid. That's when it is valid. X has to be bigger than 0. All right. Now let's look at this now, right here. It says, using Mclaren Theorem, obtain the first 4 non-zero term of sine 2x. So to obtain the first 4 non-zero term of sine 2x, we're going to have to use the same Mclaren Theorem for sine now. So now doing that now, we have our function f of x is equal to sine 2x. No worries, this is easier to differentiate. So we know that f of 0 is going to just be 0. We know that f prime of x is going to be, when you differentiate sine, how many non-zero terms they say they want? They want 3. All right, they want 3. So we need to differentiate this about 5 times to get 3 non-zero term. We differentiate sine 2x, we get 2 cos 2x. And so f prime of 0 is equal to, put in 0 here, we get 2. Then now f double prime of x is going to be negative 4 sine 2x. And so f double prime of 0 is equal to 0. Now f triple prime of x is going to be equal to, that's going to be, we plug in here, you get differentiate sine, you get cos, so that's minus 8 cos 2x. And so f triple prime of 0 is equal to, when we work that out, that is negative 8. Then finally, well, let's hope finally, f to the 4 prime of x first is going to be, when you differentiate cos, you get minus sine, so that becomes 16 sine 2x. And so f prime 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 of 0 is just going to be 0. Finally, f prime 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 of x is going to be, when you differentiate sine, you get cos, so that's 32 cos 2x. So f prime 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 of 0 is equal to 32. Nice. Now we're almost finished. Almost. Now we just need to use that Mclaren formula and then tell them, say sine 2x now, remember, is equal to f of 0, which is 0, plus f prime of 0. F prime of 0 is 2 times x. plus f prime prime, which is 0 times x squared over 2 factorial plus, then it's going to be, let's bring it up here to have some space, plus, then it is minus 8x times x cubed divided by 3 factorial of 6 plus, that is now 0 x to the 4 divided by 4 factorial, which is 24. Then we have plus 32 x to the 5th divided by 5 factorial of 120. So just to simplify everything so it looks pretty, we can just write then that sine 2x is equal to, that's 2x minus, this is 8 over 6, which is 4 over 3 x cubed. And then this one right here is 32 over 120. 32 over 120, I cannot simplify, I'm going to put it in the calculator. 32 divided by 120, which is 4 over 15. So I can write this as plus 4 over 15 x to the 5th. And this was cube right here. That's sine 2x. All right, nice. And this is the first 3 non-zero term. Nice. That's your answer. Finally now, to close out the chapter, to close out the show, we need hence or otherwise obtain the first 3 expansion in the power series of ln 1 plus sine 2x. Let's observe what will happen first. It says hence. So we know we can combine the two, right? Now, if your f of x is ln 1 plus sine 2x, let's observe what would happen. 1 plus sine 2x. If this is your f of x, let's call it f. Come by the right out f of x. If this is your f, then we know that f of 0 would be, plug in 0 in here. The sine of 0 is 0, ln 1 is 0, so f of 0 would be 0. And what would be f prime? Your f prime would be equal to, when you differentiate ln, you get 1 over 1 plus sine 2x, but then you multiply it by the derivative of sine 2x, and the derivative of sine 2x is 2 cos 2x. So in the numerator we have 2 cos 2x. And so from that now, that would then tell us that when we plug in 0 now, we could end up telling that f prime of 0 would be equal to, plugging in 0 here, we get 2 over 1 plus the sine of 0 is 0, so we end up just get 2. All right. Now it says hence or otherwise. Of course, it could have went to hence. Since I started this, we're just going otherwise. So we're going to differentiate this now. I'm going to have to use product rule. So f double prime is going to then equal to, using quotient rule, you know, we start with the bottom, 1 plus sine 2x multiplied by the derivative of the top. And the derivative of the top is, differentiate cos, we get minus sine, so that becomes minus 4. I can put the minus 4 here, minus 4 sine 2x minus the top, where the top is just the 2 cos 2x multiplied by the derivative of the bottom. The derivative of the bottom right there is when I differentiate sine, I get cos. So I get 2 cos 2x, and that's all over the bottom square. That is just 1 plus sine 2x all square. That's when I use quotient rule. Now I have no issue right here now to find f double prime of 0, but before I do that, I'm just going to simplify it to write this as Expanding it in, that would be minus 4 sine 2x. Minus 4 sine 2x. Then that would be sine 2x times sine 2x is sine squared, so it becomes minus 4 sine squared 2x. And then this right here now becomes 2 times 2 is 4, so it becomes minus 4 cos squared 2x. Cos squared 2x. I left off the 2x in here, and that's being divided by 1 plus sine 2x all squared. 1 plus sine 2x all squared. So now if you wanted to continue and simplify, I realize that I can factor out a negative 4, then I get sine squared 2x plus cos squared 2x, which is 1. So that means the f double prime gonna end up work out to be, this is minus 4 sine 2x minus 4 sine 2x, then it's just gonna be minus 4. If you want to know where I get that minus 4 from, check it out. If you factor out negative from this side, if you're to factor out a minus 4 from this right here, you'd have sine squared 2x plus cos squared 2x. And that would just give you 1. Then the 1 times the negative 4 would be negative 4. So this is what we get for f double prime over 1 plus sine 2x. And don't worry, we're almost finished. Almost finished. We're almost there. This is what we get. And so f double prime of 0 is just, we'll plug in 0, we get negative 4. Yeah, we get negative 4. So now we just need to find f triple prime, that we're done. Because it won the first 3 non-zero terms. So to find f triple prime, that's just going to be equal to, we start with the bottom again, 1 plus sine 2x all squared this time. Start with the bottom, then we multiply it by the derivative of the top. We differentiate sine, we get cos, so it becomes minus 8 cos 2x. Then we minus the top, and the top is all of that up there, the negative 4 sine 2x minus 4. Then we multiply it by the derivative of the bottom. The derivative of the bottom is we carry down the power 2, we subtract 1 from the power to get 1 plus sine 2x. Then we multiply it by the derivative inside. The derivative of sine 2x is 2 cos 2x. We close that, and then we divide it by the bottom square. The bottom square is just going to be 1 plus sine 2x all squared. Yeah, so cool it is. All right, cool. Nice. So now what we're going to get now is f triple prime of 0 is, what you're going to do is substitute 0 into the entire equation. Plug in 0 right here, so you get 1. Plug 0 right here, so you get minus 8. Close up that. Minus, you plug 0 in here, so you get 0 minus 4. Close up that. Plug 0 here, so you get 0. So that means that all of this is 0. Because this is 0. No, you get 2 times 1 plus 0 is 1. Times, put the 0 there, so is 2. Close up that over the bottom square. This was to the 4. We'll plug in this now, you get 1 in the denominator. So simplify now. Minus and minus become plus. 4 times 2 is 8. 8 times 2 is 16. So that becomes minus 8 plus 16 over 1. So that's just 8. Nice. So that means that finally we can tell them ln 1 plus sine 2x, ln 1 plus sine 2x is equal to f of 0, which was 0, plus f prime of 0. F prime of 0 is 2, so it's 2x. F prime of 0, which is 2x, plus f double prime of 0. F double prime will get negative 4. That's just negative 4x squared over 2 plus f triple prime of 0. F triple prime is 8. That's plus 8x cubed over 3 factorial, which is 6. So that works out to be 2x minus 2x squared plus 4 over 3x cubed. And that's it. Nice. All right, nice and easy, soft. All right, so finish now. Nice. All right, nice. So that takes care of this paper here. All right, nice. So finish. Nice.